evening and good afternoon from wherever you're joining from. So, we are live on Linux Foundation's AI and Data Foundation's TAC Talks. TAC Talks is Technical Advisory Council's on a live show where we bring guests from our projects um, who share their information about projects, how to contribute to the open source code, how to get involved, what are some of the features they are working on, what are some of the advancements they are bringing on to the foundation as well as the AI and data community. So today we have the project Monocle from Okahu, and for that we are joined by Pratik Verma and Prasad from the project. And I'm joining from San Francisco Bay Area. Real quick, how about the audiences? Where are you joining from? Please put them in the chat. And also, you will get opportunity to ask your questions live either through our LinkedIn channel or YouTube channel. So in case if you don't have it already tuned in, and if you have any questions, please definitely bring it on our YouTube and LinkedIn channels, and we will answer your questions right away. So without further ado, let me welcome Pratik and Prasad on the stage. Hi, Pratik and Prasad. Would you mind introducing yourself to our audience?
Yeah. Thanks, Vinny, for the intro. And super excited to be here. This would be, I guess, our sort of third time around building open source projects, starting with mostly database related technologies and now moving more into cloud and AI applications. And so Prasad and I started a company called Okahu, which is simplifying AI observability for Gen AI applications. But Prasad's the brains behind Monocle. So Prasad, do you want to share a little bit more about yourself?
Sure. Thanks, Pratik. And again, thanks, Vinny, for inviting us to this forum. Very happy to be here. So hi, I'm Prasad. I'm CTO and co-founder of Okahu. Pratik and I sort of had this idea, and we started this project Monocle and brought it under Linux Foundation Data and AI umbrella. I've been working on open source for quite some time. Was part of a lot of Hadoop related project under the SF umbrella. Worked on databases and data governance for a long time, and now focusing more on the AI and observability.
Yeah. And Prasad's being modest. He was the first one to write the first ODBC driver implementation for Hadoop Hive, right? Starting out the sequel in Hadoop. So that was pretty fun.
No, that's amazing because a lot of us data enthusiasts who has worked on Hadoop and like Hive implementations definitely have used it. So very cool to have you here. Quickly, let's bring up the background on why this project, why now, and a little bit of like what makes up the whole ecosystem right now. You brought in observability, so why is it needed? So let's share that. Yeah.
Yeah, absolutely. So on the slide here, you're going to see, the progression about how new projects have been coming under the Linux Foundation in the AI and data space. And, you'll start with Opia, and you'll see a progression where people are starting to build lots and lots of applications themselves. Now that the models are getting to a certain level of sophistication where people can start putting them into production, right? So last June, or I guess this June, a couple months ago, we introduced Project Monocle. And the premise was fairly simple. When we talked to a lot of developers, we found that people were trying to build Gen AI capabilities into their existing applications. So enhancing their existing application, be it customer support, be it generative fill in their applications, be it variety of workflow automations. So if you see on the left-hand side, you'll see a bunch of sort of design patterns for types of Gen AI capabilities that people care about building in their application. Now, if you take a step back and say, hey, how do I build it? I have a lot of options, a lot of open source options, a lot of proprietary options. So a bulk of it starts from, hey, I'm going to start some application code, some complex application, some orchestration. And so I'm going to start with an orchestration framework, be it Llama Index, LangChain. I'll write some mostly Python type scripts to begin with now. But all of these applications have one thing in common. They start with some sort of a foundational model, put some customization around it using fine tuning or through prompt engineering, some other capability that determine how this LLM actually interacts. But at the end of the day, it's great to do it on a laptop, but all of this has to run somewhere. and it ends up running in the cloud. A lot of people then build up a variety of layers on top to do model inference or app serving. And so pretty soon what you get is a sort of a pretty complex distributed application built on lots of different components. So monitoring this to figure out whether it's performant, what the quality of the application and responses are, and how does that actually behave when I want to do it at scale. Is it cost effective for me to run it so I can put it in all the different places, becomes the monitoring challenge of the time. So then we basically asked about what do people do today? So, the first thing you'll do is you go look at open source projects and you'll say, hey, I'm going to pick up OpenTelemetry. I'm going to pick up Prometheus. Prometheus is my source for metric data. OpenTelemetry gives me the ability to instrument application code and standardize a specification for how do I get tracing data on top. And if I want to do logging and build that into it, I can start using, things like FluentD. So CNCF has provided a lot of, open source project in the observability area to give you a lot of those capabilities. But when you start thinking about implementing it for the GenAI applications, you find two sort of main problems. The first problem is OpenTelemetry gives a good general purpose spec, but for me to implement that for my own application, be it LangChain or Python, I have to instrument code decoration in lots of different places. That's kind of problem number one. And then problem number two is when I get that out of the traces. So let's say if I get something from Hugging Face as a trace, and I get something from my application when I, make a call to vector databases. Now I've got two traces. I need to combine that together from the spans that are coming from the model inference and the spans that are coming from the vector retrieval in the umbrella of the application execution to really get an understanding of what's going on. And this is where the second problem lies. You end up getting different pieces of information because each system tends to implement OpenTelemetry spec in different ways. And then the problem is compounded because if I'm a user building this myself, I have to figure out how to learn the OpenTelemetry spec. Then I have to learn how to do monitoring for OpenAI, how to do monitoring for NVIDIA Triton, how to do monitoring on CloudWatch. So the complexity ends up rising. So this is where we thought of thinking, hey, there should be a utility that everybody uses, that everybody can do, that builds on top of OpenTelemetry or Prometheus, and that allows people the ability to eliminate the last mile instrumentation, a lot of the last mile GenAI specific domain code that they would have to write. And it also provides a mechanism in the open source to bring consistency. So we can have an implementation in the open source that everybody can see, everybody can comment on, communicate, and then we have a specification language or a meta model, if you will, that sits on top for GenAI domain-specific thing that makes the onboarding of the application, like your application of choice, very easy. So you don't have to figure out how to go from spec to implementation. So that's the genesis behind Monocle. So Prasad, do you want to kind of share a little bit about what Monocle looks like today, and how would somebody sort of experience it?
Yeah, sure. Thanks, Pratik. Yeah, and I just to add to what he mentioned, I want to stress that last part is the technology to walk the last mile and the meta model or the spec to share the common understanding is the most critical two pieces of Project Monocle. And that's in fact why it's important for it to be a community-driven open source project, which is why we decided to bring it under Linux Foundation. We want the end users as well as the vendors who are building these GenAI component to be part of that. So the overall application can be traced across different product components.
Yeah.
So with that, let me share my screen. Give me one moment.
So while Prasad is sharing, Pratik, I have a quick question. So you mentioned that it will take care of, traces from Hugging Face and maybe some other application. So does it take care of the format differences itself? How can it tackle all the complexities of different system? Whether it's variables or formats or all that stuff.
Yeah, absolutely. So one of the things, saving grace for us, is the fact that OpenTelemetry already exists, right? It has provided a technical format for how traces, when they're coming out, can be portable in a JSON format. So there's basically, two main sections. You'll have a span, and span will have attributes and events. Now, the hard part is, how do I represent a model inference as an event. And how do I standardize a model inference that comes from, let's say, a Hugging Face and OpenAI equivalently? So that's where the challenge lies. So what we've created with Monocle, and actually what Prasad is going to show with the meta model, is how do we basically figure out a common attribute and events sort of format building on OpenTelemetry to define a model inference as a type. And then customizations, the specific details that are different between Hugging Face and OpenAI can be handled as extensions, but the commonalities are reflected. So Prasad, go ahead. You can share a little bit about, it looks like you're jumping right into the meta model.
Yes. Can you see my screen?
Yeah.
Yes.
Okay, perfect. Yeah, thanks, Pratik. Yeah, just the term meta model, right? So both Pratik and I spend a lot of time in data governance, so it's kind of coming from that background. I know, Vinny, you hosted the Unity catalog recently in this forum, so there was a similar product that we worked on, and the meta model
Yes.
term sort of it's a way to describe the different entities have that technical specification language. So that's what we are calling this meta model. So basically, there's an entity type which says, what are my.
So you're currently in the Monocle GitHub repository that everyone.
Yes, thanks. Thanks, Pratik. Yeah. So there are different these entity types. And what is the technology component? Am I calling an OpenAI inference service, or am I talking about, let's say, an AWS Lambda function where my application code is hosted, etc.? So a consistent way of defining those entities, and then how do you, as I said, format that last mile so it is consistent. So OpenTelemetry introduces this notion of spans and traces. So span is basically it's a JSON format to describe what happened in every step of your application. So what Monocle is introduced as part of this meta model is a well-known types of the span which are relevant in the GenAI application scenarios, like your vector retrieval or your inference or your workflows, which is where your application code is running. And what are the standard attributes that are relevant to this this particular type of operation? And so when your application runs, let me show an example of the full span format. So when my application is running, there are different steps of my application. It could be, retrieving the vector from my vector store. It would be calling an inference service like OpenAI with some inputs, and then receiving the inference output with a bunch of attributes, could be related to the tokens. And then at the end of it, what was the status of my application? Did I receive it as a success, as a failure, how long it took, etc. So a lot of these attributes are related to your overall flow. And with the meta model, we are defining a way to consistently specify it. Like, what is the type of span? It's an inference span, and there are some consistent attributes for the inference span, which will say what was my input and output. Now, beyond that, let's say there will be different attributes for every inference service. I could be, let's say, calling OpenAI. Then the additional inputs that I pass to OpenAI would be very different from, let's say, what I'll pass to, say, AWS SageMaker. So we're defining what are these common attributes that everyone can understand, which are common across every type of operation, and then making this format extensible for any additional attributes that you want to which are relevant to this particular technology or this particular step that can be included in that. So that's really what that language is. It's defining what are the standards, and it's leaving extensibility in place. So it can describe accurately that individual technology component. And lastly, of course, the whole the tech stack that or the technology that Monocle brings in is for the end user not to worry about how to capture this, but simply call Monocle sort of as a single API and let Monocle do all this heavy lifting, populate this for you. So let me show that as a demo. Do you see my terminal window?
Yep.
Okay, awesome. So this is a simple a chatbot example. So what I have is a RAG pattern application. I have a local vector store. It has some very simple data related to coffee. And then I have this chatbot that
So
I can ask.
right now in a GitHub repository, like a code space or something?
Yes, thanks, Pratik. Yeah, so this is a demo GitHub, and I'm running a GitHub code space. So let's run this simple demo application without any instrumentation. Okay, so ask the coffee question. I'll say, what is an Americano?
We drink a lot of coffee at Okahu, so.
Okay, what is beer?
A lot of people resonate with that example, definitely.
Yes. In the
Way to
future
go.
demo,
I
we'll
like you threw in what's the beer. So that's how you know the response, the quality of response is great. You can let your kids have it, I guess.
Okay, so let's take a quick peek inside this chatbot. All it's doing is, I'm getting a vector store, and which is a local Chroma vector store running here, and then I simply call the OpenAI with the GPT-4o mini model, and just this is my OpenAI LangChain chain, and I just keep repeating that in a loop, ask a question, and print the response. That's sort of my simple application. Now, as you can see, I'm using a vector database here. I'm using the LangChain as my language framework to code this, and of course, I'm using OpenAI for my hosted model as an inference service. So to trace this application, I want to know what are the stages, how those components are behaving with, interacting or integrating with each other. If I don't get the right response, is it because my vector embeddings were not correct? Did my context retrieve from my vector store was not correct? Or maybe it's the choice of my model that's not good enough for the kind of responses I'm looking for? Or were there any other error? Maybe there's a network problem, maybe my token expired. Right? So there could be so many things that go wrong or deviate from what you expect when you run these type of applications in your production. And that's what the goal of Monocle is, to be able to continuously monitor that, give you that trace of that application without you having to do any additional last mile work yourself. So let's run the same application with Monocle instrumentation. I'll just run this and then I'll show the diff between. Well, actually, let me just run this first. So what is on?
You want to ask Vinny for what question she should ask the bot?
Okay.
Why is latte in every different region? Why is latte so different in every region,
Okay, so this is a quick run. I just did the same thing. I asked one question, and now it generated a trace file. So let's look at this trace. And I was just talking about, it shows me the different stages of my application run. So this is, let's say, my vector retrieval. It's talking about what was the input context. I think sometimes the output context can be really large, so we're not just printing by default. And then there are various stages of that application. Let's say about, this is when I called OpenAI. These are a lot of my model related metadata, the tokens that got used. And then finally, it gives me a summary that says, I submitted this input and I received this output. There was no failures, and how long, what about my start time, what was my end time, etc. And then to get all this, let's look at what changes I made.
The key takeaway, if you go back to the JSON, it sounds like, I think, Prasad, what you're highlighting is historically you would have had to get spans and instrumentation in each different part of the language and put lots of different agents in different places. What I'm seeing on the slide here is you just get a vector stored retriever, and the prompt and everything else along with the vector store is all pre-stitched with no extra work from somebody else.
That's correct. Thanks, Pratik, for highlighting that. And also, I was talking about the standardization that we bring in with that meta model, that whether you're using a Chroma DB or using Cosmos DB or Milvus, etc., you will see the similar top level format, like what was the input context, what was the output context, and then the additional parameters or attributes related to that specific component. So you want to see commonly what happened, you have that standard language. And then if you want to go deeper into that specific component, you have the additional details captured here.
Yeah. So if we go back to, sorry, just one more thing. If you go back to that workflow in kind of under the attributes workflow type, the workflow.langchain down below, like under the attributes one, yep, right here. And so, Vinny, I think this is what your original question was, how do we think about differences between different systems? The standardization comes in that entity type, where now we're saying, workflow.langchain, just because this code has been actually written in LangChain. If this code was written through Llama Index, the workflow entity type would be workflow.llama index. So we've grouped together the code orchestration frameworks in one category. We've grouped together all the models in another category. And so one of the things I think there's another project, Opia, that is kind of working around kind of creating a framework for models, applications, data. So we think about things in similar ways.
Yeah, cool. Thanks, Pratik. And again, sorry, go ahead, Vinny.
Yeah, and also Prasad, you mentioned earlier, like you were showcasing input context, and one of the reasons is to save storage, or like what was the reason some components are chosen to be shown here and some components are not? Because you also brought in you bring all the standardization together. So can you just add a little bit of more information there?
Oh, yeah, sure. So I think this format is still a little bit the older format. We have just, in our latest release, have put out the full spec of the meta model, and we are still aligning all the inputs, or all the formats to that spec. So input context and output context are the standard thing for a vector retrieval operation. What we have seen is a vector context, especially in a large production case, your context could be really large, and your files, if you want to look at it manually, it could become too verbose. So we are adding options about put a short snippet in the first file, and then you give maybe additional option if you want a full verbose output for every stage, versus more a summary output for each one of them. Because one of the things you have to be mindful about is the storage size. If you keep running this application, you keep generating the trace file, you will need some sort of a life cycle, you will need some storage. Like one of the features we are just building is to store this directly into a cloud store. So let's say you're running this application in a...
Where you store all these information, yes.
Oh, sorry, Vinny, could you repeat that? I'm getting some audio issues.
Yeah, I was going to ask that question, like
Okay.
how to take care of the storage, and what are some of the efficient ways you recommend to the users, like retrieving information 30 days, 10 days, like what are some of the best practices you recommend there in terms of storage too?
Yeah, perfect. Yeah, so some of the features that we are introducing in a very short term is to have a retention period. So those files will be recycled, let's say for a given, say 1 week, 1 month, etc. Also, you can only want to retain the files which has any errors, for example, right? So all you care about something when it failed, everything is running fine. You don't want to keep monitoring it. So those could be the option that you want to set based on what stage of development you are. Let's say you're in the early stage of development, or you are in your pre-prod staging area, then you want to be a lot more verbose. Once you move it to production, you can throttle it down. And also where these files are stored, by default we put it in your local directory as an individual file. As I was saying, we're just building a feature where this can be stored in your cloud store for, let's say, your application running inside a Lambda function in AWS or in an Azure function on Azure. You can write these files to your S3 store or to your blob store, or you can write it out to your log4j stream also.
Yeah. But this is where I jumped in. I mean, the way we think about it is, if the members listening to this on the TAC committee, if you're an individual developers and you're just trying to do it on your laptop or in your GitHub personal development, it'll be right there. Right. But oftentimes what happens is this tracing is not just useful in the lab development. This is super useful when things go into prod or pre-prod, right, in your cloud environment. So for that, this is where building on open source becomes really powerful, where we have an open telemetry spec, and we have, so what Prasad was mentioning is the collector that captures these traces, and we'll look at what that function looks like. There's a package artifact provided by Monocle out of the box. And that package has, some configurations that says what your verbosity tweaking is and where you want to send the location of that data to. Now, the interesting part is if you are a platform engineering team, who already has Prometheus or a bunch of other systems already in place, because we're open telemetry compatible, this is a drop-in replacement. So you just add this in and then do the management as you would. So this is where the power of having this utility in open source becomes really critical. And that's why we chose deliberately to say, hey, we want to start with open telemetry as a standpoint, because everybody has that as a specification that they're compliant with. And then the real magic isn't really like what verbosity and other things kind of have to happen. And so over time, we'll keep adding new features. And our request to the community is, if there is a file writer or exporter or a location that you care about, come and contribute to that, to the project. Or if there is a level of verbosity that you care about, or kind of information that's not currently present in the trace, add a GitHub discussion, say, hey, it would be nice if you have this. So that, let me just put that plug in for contributions here.
Awesome. Thanks, Pradeep. And then I just want to highlight, if you are using a design pattern that's fully supported out of the box by Monocle, all you need to do is, let me show the diff between the two files. It's just import the Monocle library and then call the initial API, the Monocle API, to start the tracing at the beginning of your execution logic. And you can give a name of that workflow. So all the files will be, will include that workflow name. And with those essentially 2 lines of code changes, you get all this last mile magic that Monocle is building for you.
This is my favorite like thing to show, because what that means is, instead of writing lots and lots of, telemetry function logging methods in each step in the code, which even in a simple code like this would be probably tens of lines, you're basically just writing it in one method, and it's overloading. Prasad, can you highlight a little bit about how that works?
Yes, right. And that's the main thing, is because you, as I said, this is like your application can evolve. You can include more tech components, or those components themselves could evolve, and introduce new features. So if you are doing it by hand, you are on the hook to maintain this and continue to catch up with the things that are evolving on your side, as well as on the overall technology landscape. And that's really what you're offloading to the Monocle community to take care of it for you. So let me show you so this is another part of my map. So this basically tells Monocle that for different type of the top level APIs used by, let's say, LangChain or Llama Index or Haystack, what to intercept and how to treat it. So these interceptor, the wrapper methods, and how to extract the relevant details from that particular language frameworks API has already been researched and coded by the Monocle community, and we'll continue to evolve that, as I said, as the new features that come in and the new tech components come on the horizon. We have this out-of-box map that says for every API of your Llama index how it should be intercepted. If you, as an end user, extending this and adding something new, all I guess what you need to do is define your own extension here that says, oh, my method is called foo, and this is how it should be intercepted. Or if you are somebody from the part of, let's say, a Llama index community, and you're building a whole new functionality, if it fits into one of these interception pattern, you can simply make that contribution back to Monocle, says, this is my new method and intercept it this way. But if it's like a whole new technology layer that got introduced for the first time, and that's very different, then you can simply write that extra piece of code, again, work with the Monocle community or contribute it yourself to tell us how that whole new thing should be intercepted, like how do we intercept, and how it should be fitted into that overall meta model. What should the span look like for this, and what should the entity should be named, etc. That's how the project will evolve, and that's again, as Pratik said, putting that out for the contributions. If you are somebody who is a advanced user building more extension to these existing tech components, or you are represent a project or a community vendor, this is how you can make Monocle work better with your application or your product. And then let me quickly also show a similar demo on the Llama index. So this example, I have the same chatbot, but in this case, the code is written in Llama index, and I'm using a model hosted in Azure OpenAI instead of OpenAI. And in this case, my vector database is very similar, but what I'm now using really here is the Azure OpenAI instead of OpenAI. And so the attributes are, the common attributes are still same. The additional attributes that are very specific to Azure OpenAI, which are also recorded here, like the deployment and inference point, etc. And end of the day, you still see, as Pratik was saying, the workflow type is now Llama index, but the input-output format is still very consistent. So if you're looking at this file or the previous file with OpenAI, the common factor that you care about are still there. And if you want to dig into the individual specific span, then those additional extended attributes are also there in this.
And the place where this becomes really powerful, in my opinion, is, so let's imagine you're going to do the trace. Very few people kind of consume traces on a large scale by themselves interactively. Usually what happens is this information becomes a feed to power higher level visualizations, dashboards, etc. So this is where you save a lot of energy for platform engineers who are on the other side to say, hey, I am going to get some traces out. I have to do very little data cleansing of the traces, because now my dashboard that used to work for Llama Index is going to continue to work for LangChain and vice versa, and Haystack and whatever else come in the future. And if I switch from Azure to Bedrock, no change has to happen in that monitoring. And so as a user, what I get, the value I'm getting from this is I have an artifact code, which is full code artifact I can use as it is. It's not just a specification, but the code artifact relies on a commonly open source curated meta model of entities, span types, and everything else, so that part is what we're going to maintain. So the ask to the community is to maintain that. And so from two standpoints, like that's super interesting. You eliminate the work that is needed to say which method in which framework or which Python package maps to this particular span. That's what the community is providing you as part of this particular, I don't know if it's code artifact or it's a spec artifact or kind of a JSON artifact here, but that's what you get. And then if you are a framework builder, or if you are a vector store builder, like if you're Milvus, for example, you can add your own method. And for you don't have to code a lot of telemetry. All you have to do is, hey, this function should map to this span kind, and just add that as a singular JSON file. So Prasad, could you show the Llama index and then just expand the Llama index folder on the left-hand side on the code? Yeah. What I was looking for is the map file.
Yeah, sorry,
map file. Yeah. So you would just basically add a Milvus, underscore methods.json, and then add the functions there. And that's it. And then you rebuild, and then the rest of the code will take care of all the management related things to spin this out. So this is where it becomes really powerful part of the open source community, where you can start building on top of this much more easily and get started on observability as a feature for your platform.
And like you said, Pratik, this becomes a very important tool when it comes to production applications. So when we were running a lot of data workloads before LLMs, one of the things that people hit is, where is my monitoring? We cannot handle a lot of monitoring. A lot of users are there, a lot of code we have. We have a lot of data going in and lots of jobs and this, that. I can potentially see that a lot of LLM applications will face a similar kind of phase where, where is my monitoring, where is my observability, and this can come in really handy. And I think one of the things that you also mentioned is interoperability, I guess, with different
Mhm.
clouds. So that could be very important because people want that flexibility of running it on any cloud providers they want, any models they want. So I think yeah, that could be very beneficial. Are
I'm
there
actually
any
super. So go ahead.
yeah, go ahead.
I'm
Please go
super
ahead.
excited about the OPIA thing as well, because I mean, our hope is, as you start building more and more frameworks for sort of making it easy to build Gen AI applications and moving more and more of them in productions in a wider variety of systems, observability is one functionality everybody has to have, right? It's one
Yeah.
capability. I'm super excited about how OPIA evolves. And so that way, today, from Okahu standpoint, we're thinking about, hey, cloud, because that's our expertise. Prasad and I spent, a few years at Microsoft, and then Prasad spent time at Cloudera. So, we have a thing about a knowledge about cloud, but our goal here is, as the wider community kind of sees this, they can start thinking about making connections around, hey, how do we put this in OPIA? Because you're already building a framework of creating application development and making that easy, and you just add this as a feature of that, right? And so this is where the LF data and AI seems really sort of the right.
Exactly. Yeah. Or the Gen AI Collective and OPEA, like some of these LFs initiative to standardize things or put frameworks around it, and that's why it's important for this to be a community project and part of that umbrella, so we can very well align with those projects. And of course, Milvus is a good example. It's already part of an LF data and AI project, so we definitely want to have that out of the box integration with them.
Yeah. So what are your thoughts,
Yeah,
Vinyan, around some of the other projects that are kind of built on top and how these are going around? Do you have some other ideas you want to share with the group?
Oh, sorry.
yeah.
You're asking. Yeah, okay.
No, I was asking Vinny.
Yeah.
No, I was asking
Yeah.
Vinny.
Yeah. Okay.
Yeah. So Pratik, yeah, one of the things I'm noticing is we have a lot of lot of tools and smaller models emerging now, because we have realized that um, the bigger models definitely is they are not needed for a lot of LLM applications that either are needed by corporate or either running on daily productive applications. So I kind of see this as a stack evolving. We had like tools under monitoring, we had tools under wrappers around open source LLMs itself. There are so I kind of think that all the projects that are coming under LF, we are I I'm seeing it like as an infrastructure where we have like each component tied to a specific tile of LLM landscape. And it would be interesting to see how, like you said, Opia, Milvus, all of these projects interoperate, and we kind of like have a solution for people, like, hey, these are the different projects where you can just use your applications and run like this whole stack of the projects to fit each of your production needs. It's still evolving, and I would say a lot of projects, like you had the timeline, a lot of projects are still somewhere in the sandbox phase, some are in the incubation, but we also have had projects which graduated. So there are still some announcements to be made, but that's our hope, like any project that comes to our foundation, we hopefully can evolve them, have a community going around them, interoperate with each project in the landscape itself, and graduate, so people can benefit and run more of the production applications. So yeah.
That was really interesting where you said about lots of small models and kind of local edge hosting of models, because I think I do agree. I think once you start going from, hey, foundational models in early days, you're going to see, how they play around. But at some point, you're going to start engineering these. And when you start engineering it, you have to think about not just an absolute performance, but trade-off. Hey, do I need a GPT-01 with 76 cents per query, or is my use case sufficiently small enough that I can use a smaller domain specific model and get away with it, the GPU cost being lower, or my quality versus the performance trade-off, how long do I wait for something to happen? And those kinds of trade-offs are super interesting, where I'm actually hopeful that, we've seen this small part right now of, what's possible, like early kind of wave. But as more time evolves, I'm hoping that a lot more different type of variation of model sizes, quality options start becoming in picture. And then interesting ways people can combine those models in solving business problems. And that's what we're super excited about. So that's where we think Monocle really is going to add a lot of value.
Yeah, that would be amazing. Like you said, right? This year, last year was a year where people were trying to figure out how we can all utilize this framework of LLMs and how we can be productive. But this year, a lot of people were trying to see what is practical because not everybody had the GPUs and the resources that are needed. So we realized that big data is now small data as well. You can get value from small data. So a lot of use cases have been evolving because we can do something with the small language models as well now. So yeah, that could be pretty interesting. Awesome. So I think you shared about the GitHub, and thank you for walking through the code and whatnot. Real quick, for our community to run this project, what are some other prerequisites that may not have been shared? Can you add a little bit of that too?
Yeah, I mean, of course, the standard prerequisite today, this is our first artifact is a Python library. We have started a project. There's a separate GitHub for TypeScript. It's still in the very early stages at this point. So, the first thing, this is primarily useful if you're using an application which is coded in Python. Second thing, of course, you need to install our the package, which is, of course, distributed via PyPy. So those are the two basic prerequisites that you just install the Python library. You still need those two lines of instrumenting of that code. So one of the things is you need to understand where your core application logic starts, and that's where you put the API call. If you put it at the very end, then it's not going to help you. Things like that. And of course, you will need some way where the files are stored and where they're cycled, etc. But to the very basic part, like you have application running in your desktop or in your local dev environment, and you want to try out Monocle, it's very, very straightforward. Just install a Python library, add that two lines of code, and then you can start seeing the traces out of it.
Got it. Awesome. Any other information that you want to share with the community? Anything that is coming up, either events or features that you want community to be looking forward to? Anything you want to plug in?
I'll say broadly talking about the roadmap, I'll say the three dimension. One is the technology breadth, the different infrastructure, the app hosting. There's so many of these components that can be part of your application. So we want to instrument all of them. We have started with some, and we'll continue to cover that breadth of different model hosting services, different vector databases, etc. So that's our technology breadth. The second would be on the use cases. Like the Pratik slide he showed, they talked about three common use cases like copilots, chatbots, and agentic workflow. So we want to add more scenarios to cover the agentic workflow and look for more design patterns that come in. We want to include those so somebody running that type of application get enough out of Monocle. And lastly, of course, the community engagement. Right? One in terms of solidifying that meta model and also building better integration and developing the community, get more contributors and users to try this out. In terms of the events, I guess we will be at the observability day.
We'll be at the CNCF observability day in Salt Lake City, and then at MLOps in Austin in November. So we're gonna build up a bunch of stuff in October. Sorry.
Awesome. Both are,
Yeah.
both are happening in November.
Yes, both are happening
Yeah.
in November. Yeah.
Awesome. And Prasad, back to your agentic workflows on chatbots. We also have a project called voice interoperability. So maybe you can
Okay.
talk together and see what kind of like workflow you can build.
That'd be really cool.
That'd be cool.
Yeah, we just hosted them last at the last TAC Talk, so it's pretty interesting project too.
Oh, okay.
Yeah.
Cool.
Awesome. Well, I think that brings us to our end of the session. I really enjoyed talking to you, and thank you so much for bringing a lot of insights in this TAC Talk. I know 45 minutes just went by super fast, so hopefully we can continue this momentum, and you can continue to share either through blogs and events that you're going at. So we would love to see the feedback. And if you need any help with the community, we can definitely have them tuned in with our GitHub and other resources that we have. So thank you again, Pratik and Prasad, and thank you all to listen to our TAC Talks. And if you don't know, TAC Talks happen every 2 weeks on Tuesdays at 9 a.m. Pacific time. So if you miss this one, no worries, this is recorded, so you can watch it at your own pace. It will be posted on our YouTube and LinkedIn channels. And yeah, we're gonna have next Tech Talk in 2 weeks. So thank you, Pratik and Prasad. Yeah, have a
Yeah.
good rest of
Thanks.
the day.
Thank you, Vinny, for hosting us.
Yeah.
Appreciate it.
Bye.
Thank you.